Good evening, class. So today, I will be going over lesson 3, which is titled Solving Equations. So, the first thing we need to establish is the rules for solving equations. Okay, we have been slowly building the rules between lesson 1 and lesson 2, but now we can put all of the rules together. Okay, so go ahead, pause the video if you need to, so you can see them. I also am going to write examples or like show examples of what each rule kind of looks like. So when solving equations, the first rule is well, before I say the rule, my bad. Uh, the note or the thing you should keep in mind is that you're following PEMDADs, or please excuse my dear Aunt Sally. If you don't know, that's parentheses, exponents, multiplication, division, adding, subtracting. Um, so number 1 says look for parentheses to try and solve the inside first if you can. If not, use distributive property. Okay. Now, what that looks like, okay, would be if you have, say, that's the eraser, so that's not gonna write. Give me my marker. How about yellow? Okay, so say if you have, I don't like that. Go back. Go to the pen. Say if you have 3 open parentheses, 2x, oh, hold on, back, 2x minus 4 close parentheses is equal to, no, I don't want you to solve it, equal to, I don't know, 16. Okay, so if we look at this equation based on rule number 1, right, we need to check and see if well, hold on, actually, before I go through the rules, what you need to keep in mind when you're solving equations, your goal, your objective is to figure out what value can replace the variable. So in other words, we're trying to find x. Okay, and in order to find x, we have to follow these instructions. Okay. So anywho, back to number 1. So if we look at number one says, look for the parentheses and try to solve what's on the inside first if you can. If not, use distributive property. Okay, so I see parentheses, and then I was instructed to try to solve what's on the inside. So very quick notes that I want you to see. You cannot subtract or add a regular number and a variable and its coefficient. That does not work like that because the variable or the coefficient and the variable are talking about something that the regular number is not. So they cannot be added and or subtracted. Okay. But okay, there is a special situation when they can work. Okay. I'll show you that next to not overload you. So we can't do the parentheses on the inside. So now we would use what we have on the outside, which is distributive property, or this 3. When we do distributive property, remember that means we are giving the 3 to all items inside of the parentheses through the operation multiplication. So that means this is 3 times 2x, okay, which would be 6x, and 3 times -4. So please remember that when you are solving equations and dealing with equations, what is in front of the number, in front of the variable, is very important because that will tell you if it is a negative or a positive number. A positive number will either have nothing in front of it because, we can write regular positive numbers as like just nothing with nothing there, or it will have a plus. A negative number will definitely have a minus in front of it. Okay. So now, 3 times negative 4 is negative 12. The parentheses is gone. Is equal to, stop it, equal to 16. Okay? So that is an example of the first step. I have gotten rid of the parentheses. So now another example of the first step where you can actually do what's on the inside of the parentheses. So I'll use the same numbers but change something. Okay, let's see if you notice what I changed. So 3 again, open parentheses, 2x, and this time I'm gonna do times negative 4 equals 16. Okay, so now once again we are trying to solve for x, so we would go to the parentheses first, and this time when we go into parentheses we have 2x trying to be multiplied to negative 4. So earlier I told you you cannot add or subtract a regular number, which is called a constant, and a variable and a coefficient. You cannot. It cannot work. But what you can do is you can multiply or divide a variable and a constant and a coefficient. A variable and a coefficient to a constant. Okay, basically a regular number and then a number with a variable. You can multiply or divide those together. So now we can do what's in the parentheses. So that would be 2x times negative 4, which would give you negative 8x, still in parentheses now. 3 on the outside is equal to 16. So then now you would distribute the 3, right? So then that would be negative 24x is equal to 16. Okay? And those are 2 examples of what you probably majority will see with parentheses or with step 1. A lot of the time step 1 will be more like this, where you can't do what's on the inside, but don't be fooled. Sometimes you will be able to do it. Okay? So please remember that rule of what you can't do and what you can't combine. And to be more specific, rule number 2 is about to go into depth of why you can't combine them. Okay? So if we look at rule number 2 says combine like terms. Okay? So now we need to look at what like terms are. So an example, I'll put 7x plus 3 minus 5 minus 4x equals 22 plus negative 4. Okay. So this is a long drawn out equation, right? So when you get to step 2, which is associated with combined like terms, the question is, what makes something a like term? So a like term, or something having the same term, would be this coefficient has a variable of x. This coefficient also has a variable of x. So guess what? That makes them like terms. So that would be 7x and negative 4x as 2 things you would combine. And then you would also combine this plus 3 to this minus 5. And then on this side, you would combine this 22 to this negative 4. So now let me get more specific for you. So when you are doing step 2, known as combining like terms, you focus on one side of the parentheses. Not parentheses, one side of the equal sign at a time. So if I'm looking at just this side over here, there are 2 sets of like terms to combine. I will put together these 2 and then put together these 2. Okay? Then on the other side of the parentheses, I have a pair of like terms because they're both regular numbers. Okay? Please make note, you are taking it one side at a time when you're combining like terms, okay? So if I combine like terms here, make sure when you combine like terms, you read properly from left to right. So that would be 7x minus 4x, which would give me 3x. Then 3 minus 5, which I didn't have enough, so that's a minus 2 or a negative 2, is equal to 22 plus negative 4, which would give me a positive 18. Okay? And that's as simple as combining like terms is. So most of the time, when you're solving an equation, the reason combining like terms is the second step is because after you get rid of a parentheses, most of the time you're going to have like terms on one of the sides, if not both, that you can combine. Okay. And then finally, our last step, the step that gets us our meat and potatoes and what we've been looking for, is step 3, which is known as, give me a moment, isolating the variable / getting the variable by itself. So the whole purpose of solving an equation, as I stated earlier, is to figure out the value of the variable, okay? So to do that, you would have to get the variable by itself, all right? So there is a specific way that I like to do this, and I want you guys to do it too. I want you to show your work like how you see me showing my work. Okay. And also in this specific way that I do this, I will also show you how to check your work. When you take your test, I expect to see all of that. I expect to see you showing your work very thoroughly, the way that I am showing you how to do it. And I expect you to check your work off to the side after you think you have an answer. The reason I need you to do these things is because I need to make sure that you know what you're doing when you're solving equations. I don't want to assume, I want to see it. So you have to show me, okay? There's no if, ands, or buts about that, or it will affect your grade. The right answer will only get you so much of a credit because I don't know where you got that answer from, especially with problems like this. Okay, so let's do a problem. So let's say we're doing, we'll put all of, well, let me show you what isolating the variable looks like first. So when you get to step 3, most of the time, your equation should look something like this. Hold on, let me finish it. Minus 7 equals, no, stop it, 28. All right, so most of the time when you get to step 3, just to show you a little hint, you'll have on either side, it does only on one side, but on either one of the sides, you should have a variable and a coefficient, some other number trying to engage with that variable and coefficient, and then it equals something else. That's how you know you've basically made it to step 3. Now, does step 3 always necessarily look like that? No. But majority of the time, this is how step 3 is going to look. Not necessarily with these numbers, but just the structure of it. Okay? Not necessarily minus in either. It could be a plus. Why did it do that? It could be a plus there. Okay? All right. So, moving forward, let's do step 3. So in order to do step 3, we have to get the variable by itself, okay? So the first thing we want to do is get the extra things from around the variable. This 7 is directly attached to the variable. So I don't want to mess with that until last because that would mess up my whole process and I could deal with that later, okay? So the first thing I'm going to do is get rid of this extra person over here that's trying to engage with this couple, okay? So it's a minus 7. When we're solving equations, when you're trying to make things go away or be gotten rid of, in order to make a minus 7 equals 0, we would have to do inverse operations, which means I have to do a plus 7. Okay, doing this plus 7 will make this equal 0, so basically it goes away. All right. So then I will rewrite my equation to see what I have left. All I have left is 7x is equal to 28. Okay. So now then the next step to separate this 7 and this x is I have to like basically get the 7 to equal 1. Because remember, if I get 1x, I don't have to write it like this. I could write it as just x. And solving an equation would get you where you have the variable is equal to whatever number is over here, okay? So if I continue to solve the equation, I have to know that this 7 and this x are trying to multiply together. So since they're trying to multiply together, just like I did inverse operations earlier, I need to do inverse operations now to get it to equal 1 and separate the two. So I would divide here by 7, okay? Then I would also divide here over on this side. These would cancel out or equal 1, and then I would have x is equal to 4, okay? So let's talk about some specific things with this. So first and foremost, actually, I missed a step. And it's actually good that I missed a step because now you can see why I want you to write out your steps, because it'll show you where you missed a step. So what I was about to tell you is that when you're breaking down an equation to solve it and getting things away, whatever you do on one side, you have to do on the other side. So noticing that I made a mistake, everybody makes a mistake. I missed a step up here, right here in this area, because I added 7 over here to get rid of this, but I didn't do it on the other side. When you don't do the same thing on both sides of the equal sign, it makes your equation unbalanced. And soon we'll talk about something else that has to be balanced or stay true, but that would make our equation not true anymore, so the statement would be false or the equation would be unbalanced. So to keep it balanced, you have to do the same thing. So now that I know I made a mistake, okay, and actually I could have used this to check my work, but I'll come back for that because I've seen it myself. But so now I plussed here to get rid of this, so I plus over here. So this should be 35, actually, is equal to 7x. And now I would divide by 7 to separate the two, and x would actually be equal to 5, okay? So since I did make a mistake, that is my perfect opportunity to show you, like, how I would have noticed I made a mistake by checking my answer. So remember, at first I had x was equal to 4, right? So the way you check your work when you're solving an equation is you take out the variable and put in what you think the variable is in the original equation that you were solving, okay, to prove that you'll get the same value on both sides, or that everything is equal, because the statement needs to be true that what is on one side should equal what's on the other side, okay? So doing that, right, I'm going to write it over to the side just to check my wrong answer, even though I know it's wrong, just to show you. That would be 7, open parentheses, times 4, minus 7 equals 28. Let me write 28. Okay, so I know that 7 times 4 is 28, minus 7 equals 28. Then 28 minus 7 would be 21, is equal to 28. Is 21 ever equal to 28? No, it's not. So that means that would have been my signal to know that what I had earlier before I noticed in my work that it wasn't done was incorrect, would have been right there. Okay? That would have told me right there that 4 was incorrect. Now, if I check my work again with the actual answer that I'm more confident about, if I put 7 times 5 minus 7 equals 28, I know that 7 times 5 is 35. Minus 7 equals 28. 35 minus 7 is 28. Is 28 always equal to 28? Yes, it is. So I know that 5 is the correct answer. Okay. So as you can see, solving equations can be really easy. And honest to God, I like it a lot because it checks itself if you show your work. Okay, so even before I checked my answer, you seen I looked at my work and I seen that I didn't do both things on both sides, so I knew my answer was already wrong. But just as a learning lesson, because it's good to see what's wrong and what's right, I showed you that even if I did try to use my answer I got the first time, I would have seen that it was wrong then and would have had to go back and check my work. But then I corrected myself, got the right answer, and proved that it was the right answer because I got the same thing on both sides. Okay, that the equation is true. So that means for that equation that we had, 7x minus 7 equals 28, x can only be 5 to make that equation true. Okay. So now we'll go to the book real quick because the book has like word problems, or at least one word problem that it wants you to work with. And then after that, I'll do like maybe I say 3, maybe 4 equations I'll give you or we'll do together so you can kind of get the rhythm of solving equations. And then I might give you like another 3 to do on your own. And you can come to school and ask me about it, and I'll let you know if you got the right answer or not. Okay? I think that's a pretty good strategy. But let's focus on this. So get your book and go to page 43. All right. So now we're trying to use word problems to create an equation, okay, that we're going to solve. And then once we solve it, we're going to check it to make sure that our equation is true. Okay. So with word problems, it can be a little sticky of how you do things, but I'm going to try my best to try to guide you through the situation or the problem, okay? So if we look at number 1, number 1 says, I am thinking of a number. If you multiply my number by 4 and add -4 to the product, and then take 1/3 of the sum, the result is -6. What is my number? So the first thing you need to do, hold on. Let me read part A. Part A says guess a number and check to see whether it's correct. All right. So they want us to guess a number and see if it's correct. I'm going to skip that process because we don't need to guess a number. We could just get straight to the nitty gritty and figure out what his number is based off of his description by building the correct equation. Okay. So we're basically going to go to part B. Part A isn't really necessary in my opinion, okay? So if we look at part B or try to start part B, the first thing you need to do anytime you have a word problem, you need to be able to identify what in the word problem they are referring to as the variable. Or basically, you need to find what they're calling X or what they're looking for. In this situation, he's looking for his number, right? So that means his number would be X. Okay. So now it's actually really easy. We just have to follow the process that he did with his number. And based off of what his wording, we can assume what should happen first, what should happen next, and so on and so forth. Okay. So if we go with the first sentence says that if you multiply by number by 4, add -4 to the product. Okay, so that sentence is telling us that X, which is his number, is being multiplied by 4. Then it says add -4 to the product. So since I know multiplication is happening, right, and you can only get a product if you do multiplication, that would mean that what I just wrote, which is X times 4, which is what he said happened, has to happen first. So I will put it in parentheses because remember, if we think about PEMDAS, parentheses will make it happen first. And then after doing that, you would need to add, so plus -4 to that product, okay? Then it says, and then take 1/3 of the sum. and the result should equal -6. So I know already that whatever I write once I finish my equation should equal -6. But it says take 1/3 of the sum. So there's two ways that you can take 1/3 of something, okay? You could either, since they want 1/3 of it, after we multiply this and then add the -4, because that's the only way we're going to get the sum, we have to do addition. We could divide by 3, right? Because that's going to split it into 3, which is going to give us 1/3 of it. Or, okay, because like I said, there's two ways to do this. You can multiply it by 1/3. The choice in which you do it is yours. As you can see, I put a double parentheses. So the double parentheses, the second set of parentheses is just making sure that you multiply what you did on the inside by 1/3. Okay. But, we do whatever is easier for us. Regardless if you divide by 3 or multiply by 1/3, you should get the same answer. Absolutely. And then we can set this up being equal to -6. Okay? So, let's begin solving it using our steps that I gave us earlier. All right, so the first step is look for parentheses. So let me just address something. There's only a parentheses around this -4, so that way there's no conflict between the plus and the negative sign, okay? So that's technically not a parentheses that we're trying to solve, okay? The parentheses that we're trying to solve is the x times 4. So what I have to ask myself is, can I combine x and 4 through multiplication? The answer is yes, because remember I told you you can combine a variable and a constant, or basically a variable and a regular number, with multiplication or division. That is the way you can combine them. But you can't add or subtract them, okay? So if I put those together, 4 times x would equal 4x, and that is being added to -4. Still being divided by 3 and equaling -6. If you notice, every time I do something to my equation that I'm trying to solve, I rewrite it so that way I know where I am in the problem. This is a very good method, and a method that I want you to do because it helps you stay on track. It helps you see that you did what you needed to do, okay? So now I have solved step 1, or not solved step 1, done step 1. I can move on. So the next thing I need to do would be step 2, which would be to combine like terms. I don't have any like terms that I can combine on either side. So I can't really do that. So the next step, which is the final step, would be to isolate the variable, okay? So the way the problem looks a little weird to me, because it doesn't look like how I showed you, right? Like where you would have like the 3, like maybe 3x plus 3 equals, I don't know, 6. I told y'all it would usually look something like that when we get to step 3, right? But that's not how it looks. So what I'm going to do, I'm going to rewrite this equation where it's still doing the same thing, but it's going to look the way I need it to look so I can understand how to work it. Okay? So if I should know that I'm dividing this 3, or this, not this 3, oh God, okay, come back. I should be able to recognize that I am dividing this 4x by 3 and this -4 by 3. Okay, so knowing that I'm doing that allows me to rewrite this equation where I have 4x, or let me go back, 4 being divided by 3x plus 4 over 3, this is negative, equaling -6. Okay, so seeing this, allows me to see now that I can isolate the variable, because I would be getting rid of this first, then separating the x from the fraction. Okay, so in order to get rid of a negative 4/3, okay, because I know it's being added, but it's still a negative 4/3, I would need to do a plus 4/3 because I need it to equal 0. So this would cancel out. I have to do plus 4/3 on this side. So I'm adding a whole number to a fraction, so I need to turn the whole number into a fraction. That would be negative 6/1 plus 4/3, right? In order to do this, the denominators have to be the same. So that means I'll multiply by 3 at the top and the bottom here to get negative 18/3 plus 4/3. Negative 18 plus 4 should give me a negative 14. Okay, still over 3. And then now it would be equal to 4/3. Okay, so I've run out of space, but I'm gonna go to my scratch paper to finish this problem out because we're still not done yet. And it's equal to 4/3 x. So where we were, there's 4/3 x is equal to negative 14/3. Okay, so what I'm about to show you now is very important that you comprehend how to do this, because there's two ways how to do this. One way, in my opinion, is easier than the other, but if you understand it the first way I explain it, do it that way. If you understand it the second way I explain it, do it that way. Okay, so just like before, I know that this fraction is trying to multiply to the variable because they're next to each other. So to separate it naturally, I would divide by the same thing. Divide by 4/3 on both sides. So this would cause me to be dividing fractions, right? To divide fractions, I have to do keep, change, flip. So that would be 4/3, change division to multiplication, flip it to 3/4. This is going to equal 12/12, which is equal to 1. So that means this basically goes away, and I have x by itself. Because remember, I told you if I can get x to the 1, that means I can write x by itself. And that's what that equaled, okay? So now I have to do the same thing on the other side. So that would be negative 14/3. Once again, divided by 4/3. But then I do keep, change, flip. So that's negative 14/3 times 3/4. So you can do you can find if you go across from each other, these two both have 3 in common, which would turn them into 1. So now that's 14 times 1, which would be 14. Actually, I could write it closer, which would be 14, and 1 times 4, which would be 4. So x would equal negative 14/4. You can reduce this fraction by dividing the numerator and the denominator by 2, which would mean that x equals negative 7/2. And this would be your final answer. Okay? Now, if you gave me this as an answer, I probably would accept it. But I do, like I told y'all before, I need you to start reducing your fractions. So that is one way you can get a fraction to go away from the variable, okay? So now I'm going to go back to the step that I came on here for, now that we already know the answer, and I'm going to do it a different way. A way that I think is a little easier, but like I said, it's your choice on what you think. So we already know that x is supposed to equal negative 7/2. All right. So where we were was 3, not 3/4, it was 4/3 actually. Was 4/3 thirds x is equal to, I think it was negative 14 over 3 is where we were at, okay? So another way you can break a fraction down, or basically turn the fraction into you just having the numerator as your answer, is by multiplying it by its denominator. Okay, so what do I mean? Let me give you an example. So if I have 5 over 8, right? If I want to get just the numerator, or 5 by itself, if I multiply this fraction by 8, the whole number, right? So I know that that's 8 over 1. I know that 8 times 5 is 40, okay? 1 times 8 is 8. Then I can reduce this fraction for it to equal what? 5, which is my numerator. So basically, when you multiply any fraction times its denominator, it cancels its denominator out and leaves you with its numerator as a whole number, or as the number. Okay? If you need to watch that process again, please go watch it. But that is as simple as I can make that. And that is the best example I can give you. That is the example I will give you in class, just probably with a different fraction, because it works with any fraction. So going to the fraction that I'm trying to separate from x, I will multiply this times 3 so I can cancel out the denominator. The denominator would cancel here. And ironically enough, the denominator would cancel over here because they both had 3 as a denominator. That would be 4x on this side is equal to negative 14. And then I would have to divide by 4, because remember, they're multiplying here. You got to do the opposite to separate them. So I'll divide by 4 to make that 1. And then x would equal, once again, negative 14 over 4. If you reduce that, it's going to equal this. Okay? So that's a very interesting process. I do think you should watch it over and over again until you think you understand it. If you have any questions about it, do not hesitate to come and ask me in class. But now we're going to do a couple of problems trying to follow our steps that we have for solving equations, just so we can get used to the process. Okay. So I'll give us, let's see, I'll give us this one. So 2, wait, let me go back because I need some space. So 2, open parentheses, x minus 10, close parentheses, equals 60. Okay, so, pause the video if you don't mind and try to follow the steps yourself, so we can get some of that work in, see if we can get it right. And then come back and, I'll work it out and we'll see if you do the same thing I do. Okay? All right, so you should have some type of answer that you should have also tried to plug in and, like check it, because that's what I want you to do, right? So we follow the first step. The first step says look for parentheses to try to solve the inside. If you can't solve the inside, then distribute. If I go to the inside, I have x minus 10. Remember, you cannot add or subtract a variable and a regular number, aka a constant. All right, so that means I have to distribute this 2 to x and to negative 10. So that means 2 times x would be 2x. 2 times negative 10 would be a minus 20. Okay. Or negative 20, then that would be equal to 6. That would be equal to 60. Okay, so now I'm on step 3, where I am isolating the variable or getting the variable by itself. Remember, when we isolate the variable, we need to get rid of the extra people before we touch anything with the variable. So I would focus on the minus 20. To make the minus 20 go away, I would need to add 20, okay? Since I added 20 on this side, I need to add 20 on this side, because remember, we have to keep the equation balanced. We have to keep it true. So it equals 0 over here. It goes away. I still have 2x. So now I'm rewriting my equation so I make sure I know where I'm at. 2x is equal to 20 plus 60, which is 80. Okay, and then finally my last step would be to separate 2 and x, or make 2 equal 1. So I would divide by 2 here, divide by 2 on both sides. Once again, to keep the equation equal, this is going to go away or equal 1, and now I can write x by itself, and 80 divided by 2 is 40. Okay, so now I have an answer that I believe could work for my problem, but I'm not just going to believe that. I'm going to check it and make sure I know that I'm correct. So what do I do to check it? I take x out of the original equation up here and put in the number I think should work. So that would be 2, not 2. I mean, yes, 2, but I put 20. 2, open parentheses, 40 minus 10, close parentheses, equals 60. Okay, so now we follow PEMDAS again. We can actually do what's on the inside. 40 minus 10 is 30 times 2. Then 30 times 2 would be 60. Is 60 always equal to 60? Yes, it is. So that means 40 is correct. Okay, you see that? You see how I rewrote my equation so I could keep up with my steps. I checked my work. I expect to see you do all of those things. I need all of the things to happen, okay? So now I can give you another problem that you can do to kind of test the waters. This one will probably be a little simpler than that one. And then after that, I'll give you like 3 problems to go do on your own. And we'll talk about it the next day, because it just takes practice to get this. And I mean, the only good practice is, just practicing on your own. So your next problem will be, let's do negative 7x. What does that say? I'll make sure. Okay, good. Minus 9 equals negative 23. All right, so go ahead, pause the video, see if you can get that figured out. All right. Okay, so you should have tried to figure out something. We're gonna go through the steps again like we did for the first example that I gave you. So we follow our steps. So number 1, look for parentheses. There are no parentheses in this problem, so we don't have to do step 1. So then we will go to step 2, which is combining like terms. If I look on this side of the equation, there are no like terms for me to combine. If I look on this side, there are no like terms for me to combine. So what that means is I skip that step also. So if I'm really looking at this, and remember I showed you guys this, I should have been able to recognize that I'm already on step 3, which is isolating the variable or getting the variable by itself. Okay, so remember, we don't deal with the variable first, we deal with the extra people, so I got to deal with this minus 9. So to get rid of that minus 9, I have to do a plus 9. Okay, and what I do on one side of the equal sign has to happen on the other. This turns into 0, so then I still have negative 7x on this side, which is equal to negative 23 plus 9. Remember, when we're adding 2 numbers with different signs, we're really subtracting, right? We should remember that from the beginning of the school year. So when we do this, you would borrow. Can you stop? So that turns into 1, 13. So that would be 6. No, that wouldn't be 6. What's 13 minus 9? 4. That'd be 4. Bring down the 1. So that means on this side, and then the bigger number is 23, so that's actually negative. So on this side, you have a negative 14. And then the final step, we have to separate x from negative 7. So I know a lot of people will sit here and just divide by 7. No, you must divide by whatever the number is that is attached to the variable. So since this number is negative, you are dividing by a negative. So negative 7 divided by negative 7 is a positive 1. So that means I have it correct. X is by itself. And then negative 14 divided by negative 7 is a positive 2. So now I think I have my answer, but once again, I don't just assume, I have to check it. So I'm going to put my answer back in the equation for X. So that would be negative 7, open parentheses, 2 minus 9 equals negative 23. So we follow PEMDAS. We would do negative 7 times 2 first, which is negative 14 minus 9 equals negative 23. Negative 14 minus 9. Remember, when you minus a negative, that's basically like adding the two negatives together. So if we add 14 plus 9, we should get a negative 23. Is negative 23 always equal to negative 23? Yes, it is. So our answer is correct. Okay. Please make sure you go and watch this, like I said, as many times as you need to. Like I said, it takes practice. You gotta walk yourself through the steps. Make sure you keep those steps close to you when you're trying to solve equations, to make sure that you're following the steps the way you need to. So yeah, I'm gonna give you, like, I'll say a solid 3 problems that I want you to do at home. Bring them back. Let me see what you got. Hopefully you get the right answer and you know what you're doing. Okay. So I'm gonna give you. So the first problem you get will be negative 6 x plus 8 equals negative 12. So try to solve that one. Another problem you get will be a little easier. 5x plus 20 equals 55. And then the most challenging problem is always the last one. So number 3 I'm going to give you will be 2x, what that is, plus 1/6. Is that 1/6? Let me see. I can't tell. I think it is 1/6. I hope it's 1/6. Oh, close parentheses equals 1/2. So try to do these problems at home. Remember, you have a method to check your work. I do need to see all your work. If you're going to show me these problems and ask me about them, which you should if you're trying to learn this method, and show it to me tomorrow, and have a great day.